Start. Welcome to the discuss. Today we will have a final exam review, and before that, some notes. Firstly is about the course evaluation. So I published an announcement last Friday, I think, and about I mentioned that if we have 80% of students finished the course evaluation, then every one of you will get another one bonus point. I already give you one bonus point because more than 40% of students have finished that. So if there is 10 more students complete that, so you will get another bonus point. And the deadline for the course evaluation will be tomorrow, I think, May 6th. So that if you haven't finished that, so maybe you can take it. And for the final exam, so so for the previous two, so some of the questions, all the content will be from the previous two midterm exams, so that please ensure that you are familiar with all the questions and the answers in previous two exams, midterm exams. So that's because the scope of this course. So in fact, the most important thing for this course is about the first several chapters, the application layer and the transport layer and the network layer. So for this content, they were all discussed before our second midterm exam. So that the most important things are in fact already appeared in our second midterm exam. So that please ensure that you understand all the questions in the second and first midterm exam. I already published some uploaded the answers for first and second midterm exam to the Blackboard, so that you can review these two exams using my answers. So that's very important. So and third is, so in the final exam, please try to write something. Do not leave blank, so that I can give you some points. So do not try to write something and that you know. And the last one is the cheating is not allowed. So you know that for our final exam, it will be 40% in our final grading. So that means if you cheat in the final exam, then you will fail the final exam. That will be 40 points, so that you will fail this class. So that do not cheat in the final exam. So this is very, very important. That is not allowed. So that don't do that. And for the final exam, because we will have 150 minutes from 7:30 to 10 a.m. on this Saturday, so that we need to add the number of questions. But I don't want to triple the question numbers, so that in the final exam, we will have 15 single selection questions, and each of them will be 2 points. So that will be 15 multiple 2, 30 points. And then we will have 7 open questions. Each of them will be 10 points. So that will be, in summary, it will be 100 points. And the time is 2 hours and a half. So that I believe you can finish them I think within 90 minutes, or maybe about 60 minutes. That's what I plan to do, so that the questions will be similar to the previous exams. They will not be very difficult. There will not be heavy calculation, or in fact there is very few calculation or no calculation, I think, so that you don't need to worry about the calculation. But you are still allowed to use a calculator. So maybe you will not use them, but you can still bring that. And so that's the format for our final exam. So for the things in writing in this page, do you have any question about about all the things about the final exam? And if you have any question after this class, such as when you are reviewing something, so please let me know. Send me an email, or we can schedule an appointment, because our exam will be Saturday, so that you still have sufficient time to prepare for that. So, and to make an appointment with me. And so next let's talk about the let's quickly go through all the things that will be included in our final exam. And as I said, most of the things are in fact in the before the second midterm exam. And but we can still start from the first chapter. So in the first chapter, we discussed several things, but some important things, only 3 things I think are important. So the first one is still the physical media. So we discussed that there are 3 commonly used the physical media. So this appeared in our first midterm exam: the twisted pair, the coaxial cable, and the fiber optic cable. So that's 3 physical media, and you need to know them. And another one is the packet switching and the circuit switching. So for the packet, what's the difference between them? So for the packet switching, so everybody can use the bandwidth and then send the data as long as they need. But for the circuit switching, so all the resources are reserved, so that if there are 10 users, for each user they can only get 1/10 of the resources, so that they cannot fully use the channel. So that's the difference between the circuit switching and the packet switching. So they are 2 ways. And then what is the delay? So we discussed that there are 4 types of delays. So what are them? And for each delay, why there exists such a delay? So that means you know. So what is the main reason or cause for the delay? So for example, if we also had such a question. So such as for the propagation delay, so why we have this delay and what will impact the delay? So the length, so for the propagation delay, so that is because of the length of the physical link. So if the link is very long, so then the propagation delay will be higher. And so that is the reason for the that is the main impact factor for the propagation delay. And for other 3 delays, so you also need to know them. So what is the definition and what will impact the delay? And also what is the difference between the transmission delay and the propagation delay? So this is maybe a little confusing, but yeah, you need to understand it. And the throughput, so what is the throughput? So if the bandwidth of the channel is R, and then so in fact because of some other impact, such as there is a shared channel, and then for some of the channels they cannot fully utilize the bandwidth of the channel, then what is the throughput? So and yeah, so what is the throughput for a channel? And oh, I see. Oh no. So for this one, I should yeah. So that's fine. Yeah. So for the first chapter, most important one is this layer. Sorry, this page. So what is for each layer? So how the TCP/IP model? How many layers are in them from top to down? And then this is how we discussed this textbook. And then what is the data unit in each layer? So in the application layer, it's called a message. In the transport layer, it's called a segment. In the network layer, it is called the datagram. And in the link layer, it's a frame. And then in the physical layer, it's bit. So what is the data unit for each of this layer? What is the relationship between each layer? So this is in fact the most important thing in the first chapter, because this is how we organize this class and the textbook. So that is for these 5 layers you need to know. And next is for the application layer. Application layer, we discuss several applications. So HTTP. So what is HTTP? Hypertext Transfer Protocol. And this is not important. And in HTTP, so it uses TCP, because when we are surfing in the internet, we hope to get the reliable data transfer, so that it uses TCP. We need to ensure that all the data we can correctly receive. And for the HTTP, so it has the request and response message. In the request message, there are several different methods to get or interact with a server. And then for the response message, so there are different status code. So what is for this status code? So commonly the code that we commonly see is in fact is the 404, the field not found, and the 200 that means it is okay. So it is a correct response. We can correctly get the data. So that what are the different status code mean? And we had a question in our first midterm exam, I think. And so for this different response status code, you need to know them. And for the email, so what is the SMTP? So that's just the definition. So it is a simple mail transfer protocol. So it is SMTP. And for the SMTP and the HTTP, one big difference is for the HTTP, it is a pull request. So for the user, and for the SMTP, it is a push request. So that means for the user, when she or he is using the SMTP, they can only push the data to send this mail instead of to retrieve the mail from the server. So that is the difference between the HTTP and SMTP. And yeah, still we had a question in first midterm exam. And in application layer, so the most important application is the DNS, domain name system. And what is it used for? So to map between the host name and the IP address. So for a host name such as google.com, we need to get the IP address of the google.com. So that this is the main task for the DNS. And later in the link layer, we discussed a protocol very similar to DNS, that is ARP. And ARP, it is used to map between the IP address and the MAC address. So that's the DNS and the ARP. DNS is used to map between the host name and the IP. ARP is to map between the ARP is used to be map between the IP and the MAC address. So for these two things, you can try to remember them and together because they have very similar performance functions. And for the DNS, so it has such a architecture, and for the 3 layers, what are them, and what is the main task for them. So for the for the DNS, first layer is the root name server, and then the other top level domain server and authoritative servers. And for the DNS, when a user want to get the DNS query, so how it will interact with different DNS servers. So first, it will send the data to a local DNS server. And if the local DNS server has the data, so then it will get the data directly, and it will not visit other DNS server. But if the local DNS server doesn't have the data, so then it will ask for each of the layer one by one to get the data, and then ask for the lower layer of server. And this is how the DNS gets the data from the DNS servers. So for the DNS, for the DNS, the most important thing is about this page. So for what are the name and the main function for each layer. And for the P2P, so and the client server, so very brief introduction is about the difference of them. So for the client and server, so there is always on host, and for the peer-to-peer architecture, so there is no always on server. And also it has an important feature called the self-scalability. So that means if we have more peers joining, so although they are using the services from other peers, they can also provide the service to other peers. So that when these are for the peer-to-peer system, so when there are more nodes joining, so in fact their efficiency will not be impacted a lot. So that is called the self-scalability. So this is the main difference between the peer-to-peer and the client-to-server architecture. So these two what is the difference between these two architectures? And that's for the application layer. So for each application, we will have such as one question for them. And then we go to the transport layer. So this is what I consider as the most important chapter in this book. For the transport layer, so still first is what is the definition for the TCP and UDP? I think you are all very familiar with this because we had this question in every exam, midterm exam. And what is the definition of the TCP and UDP? And for the multiplexing and demultiplexing, so for the UDP and the TCP, so for the UDP, it only uses the destination IP address and port number. So it uses two values, and for the TCP, that is connection-oriented demultiplexing, it will use four values: source and destination IP address and port number. So this is one difference between the TCP and the UDP socket. And for the UDP, in fact, it only does the multiplexing and the demultiplexing. So it doesn't do many things else. And so that will lead to the main difference between the TCP and UDP. But we can discuss this later in the TCP features. And in the UDP, another thing it does is a checksum. So still, how we calculate the checksum for UDP, and then so this is the details. So when for two 16-base integers, so we first add them and then take some calculation and take the wraparound and take the ones complement, so that we will get the checksum. So that's the last row of this page. That's the last row of the number in this page. And I also listed some more examples here. So that's from our previous slides. So still how to calculate the checksum. So yeah, we also had this question before. And so that is the thing for the UDP, because UDP only does two. The main thing it does is the multiplexing and demultiplexing. And another thing it does is the checksum. So that's all the things about the UDP. And after that, we discuss a lot of things. You can see in this chapter, the principle of reliable data transfer, the congestion control, and something else. So that means for all the following things, in fact, they only belongs to the TCP. All we can see that is the difference between the TCP and UDP. UDP doesn't do too many things, and all the following things will be done by the TCP. So that's a difference between the TCP and UDP. And for the reliable data transfer, so we discussed several mechanisms how to detect the bit errors. So we have the acknowledgement and the negative acknowledgement packet. So that will, for the receiver, it will tell the sender that I receive your data correctly or not. So there will be a bit error or not. So if we want to find the beta error, so then we can use these two packets. And if there is a packet loss, so then we will have something else called the timer and the timeout. So after the sender sends the data, then it will have a timer. And if there is a timeout and the sender doesn't receive the acknowledgement or negative acknowledgement, it will consider that this packet is lost, so that it will, when there is a timeout, it will retransmit the data. And also we use pipelining to enhance the performance of the system. If we only send one packet at any time, that would be very slow. So that we have the pipelining. So it is used for enhance the performance. And also for some other for all the mechanisms, they are listed in this table. And what is the use and the scenario? What is the scenarios that it will use and their main task? So that for this table, you need to know all these mechanisms, what are each mechanism used for. And that is for the reliable data transfer. And for the TCP, it not only includes the reliable data transfer, but also some other features or some other things. So this page includes all the difference between the TCP and UDP. So such as reliable data transfer for the pipelining, the connection oriented, and the flow control. So that's all the difference between TCP and UDP. You need to know some of them. You don't need to know all of them, but you need to know some of them. So most important, three most important thing is reliable data transfer, the flow control, and the congestion control. Yeah, we will. You don't need to remember all of them. Just 3 or 4. That should be enough. And faster retransmit. So if there is 3 packets lost, so then there will be a faster retransmit before the timeout. So that will still help us to enhance the performance. So that for the faster retransmit, faster retransmit, how many packets means how many acknowledgement, same acknowledgement packets means a packet is lost. And the flow control, infinite for this is for the sequence number and the acknowledgement number. So how to get the sequence number and the acknowledgement number of a packet based on the previous packet. So that what is the relationship between them? So for the previous packet, if it sent 42, so it means now I'm waiting for 43. So that the next packet's acknowledgement number means I'm waiting for this packet. So that the sequence number plus 1 will be the next acknowledgement number. And so yeah, this is same. And for the TCP 3-way handshake, so what is how many? So as the name shows, in fact there are 3 messages exchanging between the sender and the receiver, client or server. And then for these 3 things, what are their acknowledgement number? If we have the sequence number and of the first packet, and that is for the TCP 3-way handshake, how it works. And then what is the sequence number and acknowledgement number? For the congestion control, so the overall thing is it has 2 stages. One is slow start, and in slow start it just increase it in each round. In each time round, it will increase the segment. It will double the segment, the number of segments. And then in the second stage is congestion avoidance, and in each time round it will increase the segment by 1. So that so there are 2 stages. And more important thing is this page, so the AIMD, so and the additive increase and the multiplicative decrease. So if the in the second stage, the congestion avoidance stage, so after we receive an acknowledgement of the data, we will add the segment by 1, add the sending rate by 1. And if there is a packet loss, so then we will cut the sending rate in half. So that is called the AIMD, and then so add by 1 and cut by half. So that is how we control the sending rate. And that is for the transfer layer. So for the transfer layer, so still it's most important thing, I think. And data plan, so the most important thing is IP. But before that, so what is the router? For the router, what are the 4 things in a router? The input, output, switching fabric, and the routing processor for components in a router and their main task. And so such as for the input, so what is the main function for it? And one important thing is it will do the lookup. It will check the forwarding table to then decide where we should forward the data to. And for the forwarding table, so one thing we discussed is called the longest prefix match. So if we have, we will try to match the destination IP address to our forwarding table. But in our forwarding table, if there are several entries that can match the same IP address, then we will take the longest prefix match. And we have this question in our homework, and yeah, so that is the thing about the lookup. And the switching fabric, this is what it does. And here will be some scheduling. So if several packets arrive at the same time, how could we schedule them? So we will send them such as one scheduling principle is first in, first out, or the first come, first service. So just a different name. It just means which one come first, which one we will send which packet first. And another one is we have some priority so that the packet with higher priority will be sent first. So they are not difficult to understand. And so just one is first in, first out. Another one is based on priority. And okay, so this is not. And then the IP, so how many bits in an IP address? So we have IPv4 and IPv6. So how many bits in IP address? 32 bits in IPv4 and 128 bits in IPv6. And then yeah, how to calculate and get the IP address? So this could be maybe the only calculation in our exam. So you need to know how to get the IP address in how to change the format from the binary to the decimal IP address. And the subnet. So for the subnet, the thing is so all the IP address in the same subnet, they will have the same higher bits. And for the higher bits, we will use a thing called the setter to represent it. So if we have the first 23 bits, they are same, then we will have a /23. So that means the first 23 bits are same. And this means for the same subnet, so this subnet, it will, for all the IP address in this subnet, their first 23 bits are always same. And then the last 9 bits may be different. So that is for all the IP address in the same subnet. And if we want to get an IP address, such as when you connect to a network, such as Wi-Fi in a library or classroom, then how could you get an IP address? So one very convenient protocol is called the Dynamic Host Configuration Protocol, DHCP. And the good thing is it will automatically assign an IP address to every device that is joining, so that it is very convenient. You don't need to configure anything. And also some other features, such as they can renew its lease on address in use, and it allows the reuse of the address, and support the mobile users who join or leave the network. So that is the some advantages of the DHCP. So it's very convenient. And so for the how we get an IP address, so if we show it in a figure, so 4 steps. First, the client will broadcast and ask where is the DHCP server. Then the DHCP server will give a response and says, I have an IP address. You can use this IP address. And then the client will give an acknowledgement or a response to the server to say that, okay, I will use this IP address. And then server also acknowledges that. So then the client will use this IP address. So yeah, but for the DHCP, the most important thing are still here. So what it is used for, and what is the advantages of the DHCP. And NAT, so network address translation, we try to transfer from the public IP address to private IP address, so that now, so we don't have sufficient IPv4 address, so that we need to use a NAT to provide some addresses, provide some private IP addresses for some subnet. And what is it used for? So yeah, so and what is the advantages of it? IPv6, oh yeah, for the IPv6, how many bits? First, how many bits in the IPv6, and second, how to transition from IPv6 to IPv4 to IPv6. We discussed the tunneling. and how it works. And one detailed example to help you understand it if you don't understand it. And so we take the payload, we take the IPv4, we take the whole IPv6 packet as the payload of IPv4 and then send the IPv4 packet as normal. So that this is how we use the tunneling to transition from IPv4 to IPv6. And match generalized forwarding. So we not only use the destination IP address in the forwarding table, but also use some other headers. So in other layers, link layer, network layer, and transport layer. And then we can use the different headers to do different things, such as the firewall. So if we have an IP address, so we get the IP address and then we define such an action. So this means all the IP address from this, all the data from this IP address will be dropped. So that means we will block this IP address. So that means that is the firewall in fact. So that if we have this such a forwarding table, the generalized forwarding table. So what it does. And so that is data plan for the network layer. And for the network layer, we separate them into two parts: the data layer and control. The data plan and the control plan. And so what is the difference between the data plan and control plan? So for the data plan, we focus on the forwarding. So how we could move the packet from input to the output. And for the control plan, we will consider more about the routing. So if there is how could we find the path from the source to the destination? So there could be several routers. In the data plan, so we focus more on the one router, single router. And for the control plan, there will be more routers. And the two approaches for the control plan, one is per router control. So that is just a traditional router. So in the router, it will do two things. One is forwarding, and another one is routing. So for each router, it will do the both things. And the second approach is a software-defined network SDN, and there will be a remote controller to focus on the routing. And then for each router, it just do the forwarding. For each router, it will not do the routing. So that's the difference between the previous page and the SDN. So for the SDN, it is a software, so that we will have a software remotely doing the routing. And for the software defined network, so it has some features. So one is so we will still use a generalized forwarding, so such as OpenFlow. So instead of only the destination IP address. Second is for the control and the data plan, so they are totally separated, so that we have two parts. Third is the control plan function is external to the data plan switches, so that we can use the service provided by others. And the last one is so it is we can write some programs for doing the control, so that we can run some applications. So this is for for the SDN, so we can use it for doing the focus on the control plan. And for some algorithms, we need to know. So in general, we talk about two categories of algorithms: link state algorithm and the distance vector algorithm. So link state algorithm, so we discuss the Dijkstra algorithm. You don't need to know how to do that, but you just need to know that for the Dijkstra algorithm. So the thing is, before we run the algorithm, so all the information are already known by every node, so that it is so the link cost is known to all the nodes. And then we can do the calculation to get the cost of to get the distance from different nodes. And for the distance vector algorithm, it is different. So at the beginning, okay, no question. At the beginning, so every node doesn't know the global information. so that every node only knows the information about itself and the neighbors. And then it will update the message from its neighbors. It will update the message from neighbors, and then iteratively update the general information. And finally, it will stop. But we don't have a stop checking, so it is self-stopping. So when there is no information from neighbors, then it will automatically stop. It will automatically stop. So it is self-stopping. And also it is iterative, so that we need to run it for several rounds. And yeah, so that's a main difference between the link state and the distance vector algorithm. So for the link state algorithm, it is centralized and it knows the global information before the algorithm. So the link cost is known to all the nodes. And then when we use the product, when we use these algorithms in our real world, so we need to know the things about the autonomous system. So we have some, so as shown in this page, so for the different routers, we can group them in different AS, and then for different AS, we will have two type of the protocols. One is the intra-AS and another one is inter-AS. So we have different protocols for them. For the interconnected AS, so sorry, we will first discuss the intra-AS, and the routing algorithm will be the OSPF, the open shortest path first. So that means for an AS, and then for all the routers within that AS, we will just use the OSPF. So that is the easiest one of the easiest algorithm. And then for the interconnected AS, so we will use the algorithm called the BGP, the border gateway protocol. So for the BGP, so it is just just used to tell other AS that where I am and how could I find the other nodes. And we discussed one protocol called the hot potato, so that when we want to when one node want to find another node, so how could we find it? So for the hot potato, it means, so for a node that is getting a package, it tries to send this packet as soon as possible to other AS, to out of this AS, so that it is like a hot potato, and I will try to give this hot potato to others as soon as possible. I don't want to keep it. So that is one example for the BGP. So you need to know what is the BGP, and it is used for the inter-AS routing algorithm. So for the net control plan, so another one small protocol is the ICMP, and in fact, it is a pin. It is a pin function, so that when we are trying to pin the one destination, so then we try to find if there is a path from the source to the destination. So that the ICMP, it is used for the host and routers to communicate the information. So for the what is the ICMP and what it is used for. So you just need to know that it is trying to find a path and communicate. So that's a simple, very simple protocol. And for the last two chapters, the link layer and we will go it very fast. So for the link layer, so we discuss several things. One thing is the error detection. So for the error detection, there are two things. One is a checksum. We already discussed it. Another one is a parity checking. So it is another way to check the error. And so if we use the two-dimension parity checking, so then we can do not only the detection of the error, but also we can also correct the bit error. So for example, so we have the two-dimension parity checking, and then we can check each row and each column to see whether there is any error. And then because we have the two dimensions, so that we can find the bit that we can find the bit that is 0. And also we can fix it. So if it is 0, and so in this figure, we use the even parity checking. So that means the number of 1 in each line should be an even. So that first line, it has 4, 1. So the third line, it has 4, 1. And for the second line, it has 3, 1. So that means there could be a bit error. And similarly, for each column, we can also find the bit error, and then we can identify the bit that has an error, so that will be this bit. So for the parity checking, so how could we detect and find the bit error? In the another thing in the link layer, the ARP. So what is a MAC address? Before that, what is a MAC address for each device? It will have a MAC address, and it has a 48 bits. So so you need to know the difference between the IP address and the MAC address. So IP address 32 bits, and MAC address 48 bits. And then we want to map between the IP address and the MAC address. Then we have the ARP, the address resolution protocol. And last thing is about the difference between the switch and the routers. For the switch and the routers, they both do the forwarding, but the difference is they work in different layer. So for the switch, it would work for the link layer. And for the routers, it will work for the network layer. So the routers will forward using such as the IP address, but for the switch, it will use a MAC address. So that is for the link layer. So very soon. And for the last chapter, the wireless and the mobile network, only thing you need to know is first what is Wi-Fi. So the Wi-Fi is based on the 802.11. So that is the standard that it use. And some other daily commonly used wireless network is Bluetooth and 4G and 5G. So that is for the wireless chapter. So for this chapter, nothing else. Just what is the Wi-Fi. So that's for the chapter 7, and that's all. So you can see, so for the most important thing is still the transport layer and the network layer. So that prepare for the for these chapters more carefully. And yeah, so still for the students that missed the beginning of this class, so for the some notes, so prepare review our previous midterm exams carefully. Some questions would be from them, and also try to write something in your exam, and do not cheat. So yeah, for our final exam, we will have 150 minutes. So we will have 15 single selection questions and 7 open questions. Each open question will be 10 points. And yeah, so for each open question, it will have several sub questions. So this is same with our previous midterm exam. So that's all about the final exam and review. So still, if you have any question after the class, so please let me know and we can discuss. And also, if you have any time conflict, please let me know as soon as possible, because that we need to schedule about that. Do not tell me at a Friday and then says I cannot come to tomorrow's exam. So that if so, I could not schedule your exam. So that any time conflict, tell me as soon as possible. And that's all the things. So any questions about anything? Or you can ask me after the class. So that's the end of this class. And I have uploaded this slides to the Blackboard, and you can download it. Maybe I can. I will update it soon. Yeah, and you can download it. That's all and of this class. And thank you for this semester. And yeah, thank you. Yeah, we'll put it. Oh, I will also upload the recording of this class. Melanie?
And then, to be fair, when you brought it up, last week on Friday,
Mhm.
about me going to grad school,
Mm.
I've always thought about it,
Mhm.
you know, it's like always in the back of my mind. So I'm still thinking about it, but I think one thing that I like want to at least do before I fully decide on grad school or like fully pursue that path, I think I want to do some like research, and I was wondering if you have any open.
So you mean for the such as next year?
Yeah, next year.
And then you will decide whether you want to
Yeah.
continue. So, do you think the research will be helpful for your master degree or for your internal work?
Just internal work. I know that you also work with like security of voice assistants. And I've also always wanted to go into like a security position with
Yeah,
CS.
yeah, yeah.
So like it also like matches my interests.
Mhm.
But I think part of it, like part of grad school, like after grad school, obviously I can get a job or continue like researching on that. And I think I also want to like, you know, determine if like
Oh, sorry,
research would be
let me
like-
stop the recording.
Okay.
I forgot that.